Good to go.
All right, well, thank you everyone for joining today's call on how to accelerate moving and managing petabyte scale data sets with Microsoft Azure and our ISV partner CloudLanes. Today we'll be discussing San Diego State University as our customer reference story for this unique solution. San Diego State University was looking at backing up from terabytes up to petabyte scale data sets to Azure, and their story is the focus of our discussion today. Joining us on the call are members of the San Diego State University team who evaluated and implemented the solution, our feet on the street engagement team from CloudLanes, and our Microsoft Global Black Belt for the Azure Cloud Infrastructure, Asif Khan. And I'm Jason Lucas, a Cloud Infrastructure Solution Specialist for the Education West Region team. We will have an open Q&A session at the end of the presentation today to ensure that all your questions get answered. CloudLanes does provide a unique modern data center solution that is at the center of our discussion. CloudLanes is on a mission to establish a new paradigm in data management for the cloud-first world. They are a software-defined solution leveraging your existing virtual infrastructure. They're headquartered in Santa Clara, California, founded in 2015. They are a Microsoft independent software vendor partner, and they are currently funded by Microsoft Ventures. Now, when we're talking about working with petabyte scale workloads, 99% of the time they fall into one of these three categories, with many institutions making or have made significant investments in data analytics tools on premises. They're enhancing their multimedia footprint with improvements to campus security, body cameras, and online courses. And with approximately 80% of all this data landing in our long-term retention archives, it's becoming pretty expensive to meet the retention and compliance requirements of the institution. We know now the cloud is also presenting some compelling solutions that enable us to accommodate these business challenges, as well as provide this additional utilization of the data that's historically been left dormant on tapes or not retained at all due to these rising CapEx cost constraints. IT is obviously continuously challenged with this explosion of data, the creation, the management of the data, protecting it and archiving it. Legacy approaches become increasingly expensive as we need to ensure application uptime and availability, data replication and backup, and the logistics and the process that we've become accustomed to for securing and storing the data off-site and providing that audit trail for when and where and how the data is going to be handled. However, we've got these innovative hybrid cloud platform capabilities that provide us with this ability to then leverage these applications in new ways, also be able to use real or near real-time analytics on those applications, along with inexpensive access to the cloud-based backups and cloud economics of scale for storage. The cloud has now become an extension of the data center that's providing this new elasticity and flexibility that we need to meet these new business challenges. But the majority of all this really roots itself in the archival storage and this archival data that's causing some of these pain points and keeping us essentially from being able to leverage some of these new modern capabilities. The cloud now is providing us with a platform for that. So with that, I'd like to hand over the presentation to Ray Rodriguez from San Diego State University so that he can kind of help us with understanding what some of their business initiatives were and set the stage for us here on our presentation today. So Ray?
All right, thank you, Jason. All right, so let's go to the slide about our SDSU business challenge we have. So basically, today's SDSU business problem is also being experienced by other folks in other higher ed and outside higher ed. So this is something that we have something in common. However, in order to find out the solution, we at SDSU needed to define the problem clearly, which started about 24 months ago when we were introduced to Microsoft Azure's cloud computing and the possibility it meant for SDSU. So that was something new for us. We were looking for a simple and flexible way to move our production backups into the cloud and back on premise if needed. And we were looking for a method that allowed us to use an existing tools, i.e. backup software, in our case, Veeam and Commvault. There's nothing more frustrating as to start with some other new tool that you need to learn. And with this particular solution be presented later, that was not required. So, and the other thing we needed to do was, there are the business challenges that all organizations face in regards to the need to save money, in regards to expanding our backup infrastructure. Our backup infrastructure has been growing. The need to keep up with the explosion of data backup sets and retention demands. Everyone wants something a little bit different, but we've been constrained to offer that. And also seeking a solution that meets business objectives, that lowers capital operating expenses, and also to use the power of cloud infrastructure elasticity, which Azure for sure has that. And the other part that we needed to understand was the difference between unstructured data versus structured data before we even began to move into the cloud. So therefore, hence, the solution presented to us earlier, about 12 months ago, was ideal for us for both type of data. However, we focused first on the structured data, which was the large of the two types being generated by our backup software. And with that, we decided to tackle our problems into 3 phases that I'm going to present here shortly. Next cloud, please. In phase 1, we decided to tackle one of the larger data sets, and one of the most critical ones that we thought that needed the most attention, which was Veeam backups. We have a growing VMware infrastructure, and we also recently added Hyper-V to the mix. And it's around over 200 plus VMs and about several dozens of Hyper-V systems. Our data set for weekly backup full is around 335 terabytes, and this contracts and expands according to the demands that we need. And we also have about 15% yearly growth rate based on our averages that we've seen. And we also pretty much have done, we have a 3-month data retention policy. And this has really been a restriction imposed on us based on our infrastructure, lack of infrastructure, on ability to expand. So we're kind of limited here. And then we also have the ability, into our mix, we also have the ability to use a 10 gig WAN network. And that's relatively new to us, and then we say, well, why not? Let's take advantage of this 10 gig. And we're also using Internet too, and once we sign up with Azure, we also incorporate ExpressRoute with that. So this has all been helpful for us. This is how we have set it up with phase 1. Now we go to phase 2, which is the next slide. In phase 2, we're going to tackle Commvault. Commvault is more for the standalone systems that we have. We have a large NAT array behind it that is storing a lot of our backups, and even an EMC array. So here, but our biggest consumer of Commvault is our Oracle HR and Finance, which are running their Oracle virtual machines for databases, application layer, and the other files that go along with that. We'll also in Commvault, we're bringing in video surveillance content for our police department. They're being done daily, incrementals, and weekly. Overall, at the end of the week, it's anywhere up to 60 terabytes of full backup weekly sets that we encounter. And this again can shrink and contract. We also had to settle 3 months data retention because we're restricted on infrastructure. There was a time where we offered more, but as our growth expanded, something had to give. We had to reduce our retention policy. Okay, next slide, please. Next slide.
Yeah, we're on next slide, Ray.
Oh, I'm sorry. There was a little delay here. I'm sorry. So in phase 3, we're going to take that video surveillance archiving data that we're taking. and move it into this other, take it outside of Commvault and move it into this phase here where we'll back up the campus security video. It also has some other uses for it because we also thought, why not classroom lectures archived for professors, where they have some critical lecture they don't want to lose. We can take a copy, put it up in Azure, for instance. So there's all kinds of possibility with the next phase, and in my opinion here, there's even more explosive, more creative ways to use this particular content, this technology. It supports NFS, CIFS, and SMB, and on average is about 4 to 5 terabytes per month, but this capacity is limited by the local storage on the video server. I believe if they had unendless capacity, this growth would be much bigger. Right now, it's about 5% data growth as we see, and once again, we're locked into a 3-month data retention policy, just like the other projects for Commvault and Veeam. And with that, I'll pass over to Asif, who will tell you the rest on how it's done. Thank you.
Thank you, Ray. Good afternoon, everyone. My name is Asif Khan. As Jason introduced me earlier, I'm with the Global Black Belt Group for Azure Cloud Infrastructure, and I was part of the team that put this architecture together. So I'll be spending the next few minutes talking about how we came to put the design that we finally put together, and talk about some of the thought that went into that. I just want to very quickly mention that for those of you who have questions while I'm talking, please feel free to enter your questions in the chat window, and then after we're done, we have left about 10 or 15 minutes at the end for additional questions if you have any. So with that, why don't we get started? So when we approach the how do we do this, to address the business requirements that Ray laid out, first thing we did is we broke it into 3 phases, and then we decided, okay, we need to put together a solution that can handle all 3 phases and then grow beyond that. As Ray mentioned, one of the constraints that they faced with their on-site archiving strategy was that they were running out of space, and so even though they would like to keep some backups longer than 3 months, and they'd like to keep their campus surveillance video for longer than 3 months, they were just running out of physical storage space, so they couldn't do that. So if they had a platform where they can expand and store some of that data longer, that would be something of interest to them. So the first thing we did is we did a bandwidth and capacity analysis for all 3 workloads. So we combined the 3 workloads. We said, okay, once all 3 phases are in place and in production, what are our bandwidth and capacity requirements going to be? So when we looked at the bandwidth, we just did a very simple calculation. We said, okay, we have a 10 gig WAN network available to us. Let's just assume that there's going to be some latency, some overhead, some network overhead, as well as maybe some light usage by other people or other users. And so we estimated that we would have 8 gigabits available to us at any given time. So given that we have 8 gigabits of bandwidth and we have 96 terabytes of data that we need to upload every week, this 96 comes from what Ray just described. Phase 1 was 35 terabytes of Veeam backups, and add to that 60 terabytes per week of non-virtualization or non-VM backups, and then another terabyte per week for the video. So 96 terabytes of upload, and we just made a assumption. We don't know what the actual number is going to be. It could vary from this, but we made an initial assumption that we're going to have a 1% egress rate. That means every week the customer is going to be downloading about a terabyte worth of data for testing purposes, reporting purposes, data restore purposes. So 96 up, about 1 terabyte down. We estimated that it would take about 27 and a half hours to do this data transfer per week, or a little more than a day. So we can essentially set the backup to happen on let's say a Saturday morning, and by Sunday morning it would be done. However, we don't necessarily have to set up a backup window, because this was designed, because we have the bandwidth available to us, we can just have the data be uploading as soon as it lands on the landing zone on the local disk and be ready to move up to the cloud. So we determined we had plenty of bandwidth to do this. The next step was to determine what kind of capacity requirements we have. So this is an ugly graphic. It's a very busy graphic, and I hate to show busy graphics, but I wanted to emphasize a point here. When we take that 96 terabytes per week, and to get a monthly amount, we multiplied it by 4 weeks in a month, and then we added the expected growth rate, which, as Ray pointed out before, is somewhere between 5% and 15%, depending on the workload. So with that, for the first month, we got about 393 terabytes. You probably can't see these numbers, so I'll just read them out to you. 393 terabytes in the first month, keeping in mind that each of these full backups are already deduplicated, compressed, and encrypted. And so we're not going to get much more reduction of that data. So every time we send a full backup to the cloud, it is going to take the full 96 terabytes. So 393 the first month, and then we add another 393 of additional backups from the second month. The first month still remains, and then by the third month, we have 3 months worth of data up there. And by the fourth month, the first month gets deleted because the retention policy is over, and then from then on, we keep 3 months worth up in the cloud. And as you may be able to see here, the writing's kind of small. By the time we get to the 12 month, we're looking at close to 1.3 petabytes of data stored in the cloud. And that number will grow only based on the growth rate that Ray pointed out earlier. Okay, so now let's get into the architecture of how we handle something with a capacity requirement as I've described. Before I get into the SDSU architecture that we put together for them, first I want to start off by doing a cloud backup and archive 101. Most customers I speak to, they have a need for long-term backups, and they don't really have a specific archive strategy. On the other hand, I speak to a lot of healthcare customers, and I speak to financial services and other industries that are heavily regulated, and they have some very specific compliance requirements and definitions around backup and archive. For the purpose of this discussion, I'm going to keep it at the very basic level, to where we describe backups as protected data that's 30 days old or newer. And archives is anything that has to be kept longer than 30 days. So you might have a need for keeping something for 30 days and you can just get rid of it. And then there might be other data that you want to keep longer than that. And so anything longer than 30 days we're describing as archive. I know that's not very scientific, but the reason we chose 30 days is most customers I speak to, and this is kind of a de facto industry standard, is that if you're going to be restoring data, 99% of the time, you will be restoring it from within the last 30 days. There's very, very few instances where you need to restore something older than that. If you do, it probably means you have some devastating attack on your data, meaning corruption or deletion of data, and you have to go back quite a ways to pull out the last known good, or you're going through some kind of audit or something like that. So, having said that, the way it works, it starts off with a data protection software. So this is your backup software, if you want to call it that. It's your net backup, your backup exec, and in SDSU's case, Veeam or Commvault. It could be EMC Networker, it could be TSM, it could be Microsoft Data Protection Manager. Whatever backup software you use, they all work pretty much the same way, in that once the backup data has been sent to the device, it puts it into local cache where it formats it into an image, creates some metadata tags, and then sends it off to a backup target. And usually this backup target is disk-based, and it's a file system where the data protection software can go in and do things like dedupe, like compress, like encrypt or decrypt, do item level restores, do volume level restores or image level restores, do things like pruning and checksums, consistency checks, data validation, things like that. So you're constantly touching that data. So it's good that it's sitting on a disk operating system or a disk file system, and that it can be manipulated pretty easily. Now, how the cloud gets introduced into this architecture is through something called a connector. Now, most backup software or data protection software vendors today have a connector that's available usually as a plugin, and even if they don't, there are some third-party connectors out there. So the connector is just a plug into the main software, and then it communicates with a cloud broker that's sitting in the cloud, and this would be a media agent or a media server or whatever you want to call it. Different backup software vendors have different names for them, but essentially it's a cloud broker that acts as an extension of your data protection software on site, and it receives the data through the cloud connector and then puts it into active storage. Now, once it's in active storage, you can do with it everything that you would do if that disk were sitting local in your site. All the things I mentioned before: item level restores, deduplication, pruning, consistency checks, data validation checks, things like that. You can do it all. You have complete control. You're completely integrated. The only downside is that it can get expensive. The active storage as well as the cloud broker itself, you need a fairly hefty VM to handle all the operations that are being done on the data. You need sometimes you need fast disk like premium solid state disks to handle that data. So if you're going to keep it for any length of time, then it's good to take that data and send it off to an archive target. Now, an archive target works very differently in that once your data has been backed up to your data protection software, sits on local cache, gets formatted into an image, and then gets exported as though it were being written to tape. And so the idea here is that in traditional IT shops, it would get written to a tape. That tape would get put on a truck and be sent off-site to be stored, to be vaulted in a warehouse. Now, how the cloud plays into this is that instead of using tape as your archive target, you would also use disk, but you'd have an interface called VTL, or Virtual Tape Library. And so that VTL interface makes it look to the backup software like you're sending the data to tape. Okay, so it thinks you're sending it to tape, but you're sending it to disk. And once you send it to disk, there are some pretty interesting things you can do with it, like replicate it to another site. Or in this case, if we're going to introduce the cloud, we can use something called a cloud gateway and send that data directly into passive storage. So the cloud gateway is nothing but a protocol converter. It takes that VTL interface and converts it into an object interface or REST API interface so that it can communicate directly with cloud storage. Now, the difference here is that on the left side, you have the cloud backup where you get the high level of integration, but at a higher cost. On the right side, you have it's essentially the same as sending your tapes, putting your tapes on a truck and sending them off site, but it's better in some ways because you can just pull it back very easily, just over the wire. The difference in cost per gigabyte between archive and backup could be substantial. It could be where the cloud backup, using the cloud broker, using the active storage, it could be sometimes 15 to 20 times the cost. And so there are very different purposes. If someone tells you that, well, we tried cloud-based backup and it was just too expensive, they probably tried the architecture on the left. When if they have a lot of data, they might want to consider using the architecture on the right. As your data grows, as the amount of the volume grows, then the architecture on the right sometimes makes more sense. Now, most backup vendors are blurring the lines between the two, and they're adding capabilities from the left to the right and the right to the left and all that. So this is a nice depiction of the two different ways you can back up to the cloud, but in reality, the lines are getting more and more blurred. Now, the question is, if backups are up to 30 days and archives are longer than 30 days, then it stands to reason that all archives were once backups. So the question becomes, how do you take the data from the left side and move it to the right side? Well, there's a few different ways of doing that. One is that you can have a cloud-based gateway that can take your data from that cloud broker and go through that same conversion process, having a VTL interface on the front end and having or an NFS or CIFS interface on the front end, and then having a REST API interface on the back end, and send that data to passive storage. The other thing you can do is instead of sending data to the cloud for backup purposes at all, just keep it local and just add additional disks so you can keep 30 days worth or even longer if you choose to do that. And then after that expiry period, then you can send it off to an archive target and send it up to the cloud via gateway. The third way is just to increase your bandwidth on your network connection to the cloud. And if you do that, then you would be sending it up to the cloud. You wouldn't have direct access to it, but you can pull that data back pretty quickly. In the case of SDSU, as Ray mentioned earlier, they had a 10 gig connection, which makes it very, very nice to be able to pull a lot of data down very quickly if needed. All right, so with that, I want to get into the specific architecture that SDSU chose. So when we approached them, this is the way they were doing things, and we originally identified the VM environment, which is VMware and Hyper-V. I didn't mention that on here. So the hypervisor environment was backing up to Veeam, or is backing up to Veeam, and from there, for short-term storage, for the backup portion of their data protection scheme, they were sending it to a Dell Compellent storage array. And from there, after 30 days, it was being sent to a quantum tape target. The goal, as SDSU shared with us, is that we want to get rid of the tape because of the expense, because of the complexity, because of the unreliability. We want to move to something else. So what can we look at that can take the place of tape without having to change the way we do things today? And then they also pointed out to us that in addition to our VMs, we also have our physical environment, and then we have our video feeds that we'd like to incorporate into this solution. And we don't want three different solutions for these three different types of workloads because we have other workloads we might want to add, and we don't want to keep coming up with a new solution or a new architecture for each different type of workload. So we want one consolidated way of doing things. So that's where the CloudLanes solution came in. We talked to them about a number of different ways we can do this, and after evaluating a number of different options, we mutually decided that CloudLanes was the best way to go. All three workloads could interface with the CloudLanes Archive Manager, and the Archive Manager would send the data to the cloud through basically one single stream. So what I want to do now is I want to drill down into what this architecture looks like and what we did at each level by talking about the different boxes here in terms of pillars. So or tiers. So we have the source tier where the data is sourced, and then we have the package tier where we're packaging the data. Then we're sending it to a transfer tier to transfer it to its final target, and then we have the actual target, which is the cloud. So starting with the source, as we mentioned and as Ray mentioned, the three different workloads are the hypervisor, the physical servers, as well as the video feeds, and these generate different workloads. And I'm not going to spend a whole lot of time here since Ray did a great job of describing this, but we're basically snapshotting, consolidating, and streaming that to the data packager, which we'll talk about next. So the package tier is what takes that data and encrypts it, compresses it, in some cases deduplicates it, and then sends it off to, it does all that in the backup software, and then sends it off to the transfer tier, which is the CloudLanes. So, and Ray talked about all this. I'm not going to spend a lot of time here on this either. But for the VMs, it's Veeam, it's backup software. For the physical servers, it's Commvault. And then for the video streams, it's a video archiver. What a video archiver does, it takes the video streams and it breaks it up into 10-second segments, so that if you wanted to see video from 153 and 30 seconds until 153 and 55 seconds, you can see that segment, and the video archiver is the one that that splices up the data in those time slices. Okay, so with that, let's get to the transfer tier, which is the CloudLanes appliance that we've been talking about. And the way this works is, remember I said that there's backup and then there's archive, the two ways of integrating with the cloud. And I showed them as two distinct ways of doing it, but there's been a lot of blurring of the lines between the two. So CloudLanes is a great example of how they took the best of both worlds and developed a solution that's tailor-made for archive data, but with a higher degree of interaction. So the way CloudLanes works is that you have your data packaging tool. In this case, the three different tools are Veeam, Commvault, and the video archiving tool, and it communicates with the input ports of the CloudLanes Archive Manager. So the input ports are basically, you have one of two options. If you choose disk, that would be like a NAS interface. It would be a UNC path or a mount point using NFS or CIFS. And then you have the tape interface, which is VTL. So if you have your Veeam or your Commvault and you want to tell your Veeam or Commvault that I want to send this data to tape, then the CloudLanes has a tape input and it also has a disk input. So once the data is received into the CloudLanes Archive Manager, it sits in local cache, and then metadata tags are added to that data, and these tags are kept local. So even if we lose connectivity with the cloud, we lose connectivity with the actual data that's sitting in the cloud that CloudLanes has transferred to the cloud. We still have the metadata so that we can feed it into the cataloging and be able to do reporting against it as far as what data we have and the age of the data and the retention policies and all that. So once the metadata tags have been added, then we decide, does that data stay local or does it go remote to the cloud? And so how we determine that is that, or how SDSU has determined what they want to do, is that they want to keep the most recent full backup. So remember, we're doing weekly backups for the 3 different workloads. They want to take the most recent weekly backup or the full backup, and then all the incremental since then. So let's say a full backup was taken on Saturday, and now it's Thursday. So we have the full backup from Saturday, and then we have all the incrementals every day since then. Those are kept local. So if you want to do a restore from that, then you can do it from your local storage. You don't have to go out to the cloud to get it. Everything else goes to remote storage, goes to the cloud. Now, one of the killer features of this solution, and the reason that SDSU chose this over several other options that we're looking at, and it's pretty impressive. They had a research lab where they were looking at a lot of different options, and they had the luxury of being able to try out all different types of solutions. One of the key reasons they chose this solution is, very simply put, the speed. So we looked at other products like Store Simple, which is a Microsoft product. We looked at Data Domain, NetApp's AltaVault, and several other solutions, and most of them tended to have pretty good speeds. They averaged from somewhere between 100 megabytes per second to 150 megabytes per second. And as you can see here, if you can read this, the upload speeds we're getting with the CloudLanes for a single stream, and that's key to us. For a single stream, we're getting 668 megabytes per second, which translates into 5.3 gigabits per second, which translates into 2.3 terabytes per hour. So imagine you had a VM that has 2 terabytes of disk on it, or you have a backup image that's 2 terabytes in size. Imagine being able to download it from the cloud in about an hour. Pretty impressive. The download speeds were in our initial testing were not quite as fast. Since then, we've been able to get a little bit more parity between upload and download speeds. On a sustained basis, our upload speeds are a little bit slower. Rather than 5.3 gig, it's more like 4.5 to 4.8 gig. But then our download speeds also went up from 3.5 to something like 4.5. So we're able to continue tuning the parameters to get our speeds higher. But as you can see here, having a 10 gig pipe, if we wanted to saturate that pipe, we can just start up a second stream of backups and be able to saturate that pipe. If you happen to have, if you're lucky enough to have a 40 gig pipe available to you, we can set up multiple streams and be able to saturate that 40 gig pipe. So a lot of capability here. The ability to upload very quickly and download very quickly was a key reason why SDSU chose this, and it made a very cost-effective solution for them to deploy. Now, getting into the final piece of this, and which is the target, which is once the data goes to the cloud, to the local devices, to the backup software, to the archive manager itself, it just looks like a tape target and a disk target that we sent the data to. In reality, it's just sitting in Azure storage, but it's emulating or replicating a tape or a disk target. The disk target obviously would be for the video data, and then the tape target would be for everything else, the Beam and the Commvault backups. Now, this is what SDSU's cloud architecture looks like today. Everything is just being put into Cool Blob Storage, which is our lowest cost storage offering. And as far as a future phase, what SDSU plans to do is to bring up the CloudLanes Archive Manager in the cloud. So they have the on-site appliance, and then there's also a cloud component. And what that cloud component does is that it gives you access to other services in the cloud. So you can take your data And using CloudLanes, you can export it into other Azure services, integrate it with things like media services, or take data and put it into a data lake and use Hadoop to do analytics against it. If you have a lot of log files and you want to feed it into a Splunk implementation, or Microsoft's own OMS log analytics platform, you can do all that. CloudLanes allows that data to be freed once it's in the cloud, and that's a big differentiator for them. The other thing that it does is that the CloudLanes Archive Manager in the cloud can take care of a lot of the data verification processes. So whether it's consistency checks, whether it's just checking on the validation of data, sending reports back to the backup software. It can do a lot of the verification and validation on site. And then the final thing that it does is the data lifecycle. So let's say, for example, Ray mentioned that in overall or on average, they have about a 3-month retention policy. So what happens when you reach 3 months in a day? Instead of having to pull that data down in order to delete it, you can just use the CloudLanes tool to set up policies where it gets deleted in the cloud once the retention policy is up. So having said all that, I want to take just a couple minutes and show you some screenshots of what this looks like, because I've been talking in terms of abstract solutions, but I want to show you what it actually looks like. So when you pull up the CloudLanes interface, it looks like this. This is the dashboard. It's just a web interface. And when you go in, you can see things like the capacity being used, the local resources being used, the status of backup jobs and things like that. This is the main dashboard. And when you're doing the initial setup, you do it through this interface. And so once you've looked at the initial dashboard and you want to drill down into the tape library, you can see, you might have a hard time seeing this, but what it's showing is that I have the CloudLanes looks like an emulated tape library to your backup software. So this emulated tape library is called STK I700, I think. I'm having trouble reading that myself. But it's an emulated tape library, and you can specify how many tapes it has, how many disks it can handle, and what kind of disk it is, and what kind of tape reader it is, and other parameters. So you set it up so that it looks like a tape library to your backup software. So earlier this morning when we did another session, somebody asked if this works with EMC Networker, which doesn't have a cloud connector or cloud component. And so if you're using something like EMC Networker, this is a great solution, because as long as your backup software can read tape, the CloudLanes can attach to it, and there's no change in your data flow or your process flow. You just set your CloudLanes device up so that it looks like a tape library, and you point your backup software to it. In this case, I'm going to show you what it looks like from, and again, this is very small, so very hard to read, but this is a Veeam management interface. And so what we're doing here, and I know it's really hard to see, but if you look at the very bottom, the blue line, that just says tape infrastructure. So if you click on tape infrastructure, you go up to the top, and I can't even see this, but you click on tape infrastructure, you click on tape library, and the CloudLanes 1500, which is the model number, shows up as tape 1 and tape 2. And then you click down on media, and it'll show the tape it'll show the tape media as CloudLanes 1501 and 1502. And then when you click on media, it shows you the list of all the tapes. The second column shows whether they're local to the device or if they're in Azure. You go a few columns down, it'll show you what the retention policy is, or if there is a retention policy, and it shows you what the capacity is of that tape, how much of it is used, how much free space is on there. So as far as Veeam is concerned, it's just connected to a tape library. It has no idea that it's the CloudLanes device and it's sending the data up to the cloud. Okay? So with that, I'm going to turn it back to, I'm sorry, I'm not going to turn it back to Jason. I've got one more section to do. I'm going to pause here for a minute and see if there are any technical questions before I go into the why SDSU chose this solution over all the others, and it's really looking at the financial analysis. So, and I should have worn my glasses. I'm having trouble seeing here. How many Azure storage accounts were used per CL appliance? CloudLanes friends, do you want to answer that question?
Great.
I'm sorry, was that Ray?
Yeah, it's three accounts you need. Mm-hmm.
Okay. Three accounts used. Brian, does that answer your question? Do you want some more detail on that? He says, thanks. Thank you, Ray. Any other technical questions before we get into the financial analysis of this? All right, great. So let's talk about the why. Why SDSU chose this solution, and the software supports up to 8 accounts. Right. So why did SDSU choose this solution? We're going to go into the different costs involved. The reason that they gave us is that they wanted to save money. They wanted the elasticity of the cloud. Sometimes they want to store data for longer periods. Sometimes they want to cut back on the retention policies, and so they like the elasticity of the cloud. They wanted to simplify. They had different types of workloads, and each one was using its own backup and archive solutions, and so they wanted to consolidate that all of that into into one simplified backup and archive environment. And finally, they wanted to modernize their data center by using the latest technologies out there, such as cloud, to see how they can get the scale and the economics of using the cloud. So with that, the first thing we did is we compared the different storage costs for different archival strategies, and we determined, and we used a lot of assumptions here, capacity cost, transaction cost, access costs, all of that combined. We came up with a cost of $220 per terabyte per year. There's a question about how many CloudLanes appliances were used, installed. That's a great question. I forgot to mention that. I showed one box, but that was not the physical architecture. That's just the logical architecture. There are actually going to be different, and by the way, they're not boxes, they're VMs. So you can download as many as you want and run them on your Hyper-V or VMware environment. SDSU chose to run it on bare metal hardware, so that's an option as well. But it's just a VM, and so you can download as many as you want. What SDSU did is that they're running one for each of the different workloads. So one for Veeam, one for Commvault, and one for the video. Ray, is there anything you want to add to that?
No, that's about right. Okay. That's what we're doing. We
Okay.
will be doing.
All right. So so we estimated that the cloud, all in, given a reasonable amount of transactions, a reasonable amount of access, would come to about $200 per terabyte, $220 per terabyte per year. Tape, on the other hand, if you take into account the cost of media, the cost of the tape library infrastructure, as well as the vaulting costs, offsite warehousing and vaulting costs, comes out to be about 405 terabytes per year. When we looked at disk, there's a much greater variance because it depends on what kind of disk you're using. Is it just a Dell or an HP server with some local disks attached? Is it an iSCSI array? Is it a fiber channel array? Is it an enterprise class array like an EMC Symmetrix or something like that? So there are a lot of variables as to what the cost of disk would be. So we decided to drill down a little bit further and look at the 48-month TCO, total cost of ownership, for SDSU's storage environment. So the first thing, and we broke it down into per gigabyte per month. So the first thing we looked at is how much did you pay for your storage hardware, and then how many terabytes is it? Let's break it down into gigabytes and amortize it over 48 months. And we came out to a very reasonable cost of 0.9 cents for their compellent array. Now we add to that the software and support. And the rule of thumb is that usually whatever you're paying for your hardware, you're going to pay the same amount for your software, and you're going to pay the same amount for your support over 4 years. So each one is a third of the total cost. So the total cost of the hardware, the software, and the support over 4 years comes out to be 2.7 cents per gigabyte per month. And then we add to that the capacity sizing. So, for example, there's RAID overhead. If you configure your disks to be RAID 6, there's some overhead associated with that. If you take into account online spares, snap reserves, and other capacity reserves, then we're looking at about 30% overhead to your raw capacity. Add to that, and I keep forgetting to change the second part. It shows base 2 to base 10, but it should actually be base 10 to base 2. What I mean by that, and not a lot of people think about this, but it's significant, is that when you go out to Best Buy and you buy a disk, and let's say you buy a terabyte disk, they count a terabyte as 1,000 gigabytes. And when you're using base 2, as we do in Azure, a terabyte is not 1,000 gigabytes, it's 1,024 gigabytes. and a gigabyte is 1,024 megabytes, and a megabyte is 1,024 kilobytes, and so on. So you're actually getting, when you buy a petabyte of Azure storage, you're actually getting 13% free. In other words, for every petabyte of Azure storage that you purchase, you're getting 130 terabytes for free, if you want to think of it that way. So you're not getting that when you buy your on-site storage array, because most on-site storage vendors, they use base 10. So a terabyte is 1,000 gigabytes. A petabyte is 1,000 terabytes. So when you take that type of overhead into account, we add a multiplier of 1.43, and that brings our cost to 3.9 cents. Then the other component is capacity utilization, meaning that if you buy a 100 terabyte 100 terabyte storage array, you're not going to use all 100 terabytes. You're going to get to about somewhere between 70 to 80% utilization, and then you're going to see performance degradation, at which point you're going to say, okay, my device is full, I need to add more disk, or I need to buy a larger array. So we estimated SDSU's max usage to be at 76%. So we're counting that 24% as unusable space and a cost, and there's a cost associated with that. And then we also talked about ramped usage. So, for example, if you buy that 100 terabyte storage array, you're not going to use up 100 terabytes all at once. You're going to be ramping up to it over the course of 3 or 4 years. So, taking that into account, we added a multiplier of 1.44. These are based on fairly standard industry numbers, and we customized it a little bit to meet SDSU's specific case. But then there are some other costs which we didn't take into account. For example, facility expenses. Because facility expenses comes out of a different budget, it's not considered an IT cost at SDSU. So we didn't take into account things like the real estate where the devices are sitting. We didn't take into account power costs and cooling costs and cabling costs and racks and all that stuff. We didn't take any of that into account. We also didn't take into account something that is actually pretty significant, but we consider that a soft cost, so we didn't include it here, but it's price erosion. So, for example, you buy a 100 terabyte storage array today, and next year the cost of storage goes down, whether it's buying another storage array or whether it's cloud storage. Cloud storage has typically gone down by about 25% year over year. As an example, when I joined Microsoft about 4 years ago, a gigabyte per month used to cost about 13 cents. And today our cheapest offering list price is about a penny. So it's gone down quite a bit, and so there's a value to that to price erosion, and we calculated that to be 25% year over year. And then there's also the refresh cycle data migration. So every 4 years, if you buy a new storage array, you need to migrate your data over. Again, there could be a significant cost associated with that, but we consider that a soft cost and didn't take that into account when we did our calculation. So we stuck with 5.6 cents as the cost of on-site storage. Then the next thing we did is we took that 5.6 cents and we compared it to cloud costs. Now, some of you may know that in Azure we have two flavors of storage, or I should say two flavors of object storage, which is hot blob and cool blob. Hot blob is for your data that's hot and has a lot of transactions. So we charge very little for transactions, but we charge more for capacity because this is the active data and you're accessing it all the time. And so we charge you very little for transactions, but we charge a little bit more for capacity. Then there's cool blob. And cool blob is just the opposite. The underlying technology is exactly the same. It's just two different billing models. So if you choose the cool blob option, then you're going to pay a lot less for the capacity, but we assume that you're going to put a lot more data there, so we're charging a lot less for capacity, but we're also assuming that you're not going to be touching that data very often. So the transaction costs are double, or they're higher. So high transaction cost or high capacity cost, those are the two choices you have when it comes to object storage. So here we looked at both options. If SDSU were to go with a hot blob and assume they're going to be touching that data all the time and constantly using it, they would see a 37.5% savings compared to an on-site storage array. And then, so that's for hot blob. If they went with cool blob, what they would see is a cost of 1.6 cents per gigabyte per month for a 71.4% savings. So it became pretty much a no-brainer that you can do this. Now, somebody asked when we did this session in the morning, somebody asked, well, does that take into account the fact that you have to have a network cost? And no, it doesn't, because SDSU already had the network in place. We didn't take that into consideration. But if you do have to add to your network to do this, we think the savings are still there, where you're still going to see savings. Maybe it won't be as dramatic as this if you take into account the cost of the network, but you'll still see a savings compared to on-site storage. So comparing hot blob to cool blob, we were able to realize these savings, and the most significant thing of all is that the pricing I'm giving you here is not the secret deal that we worked out with SDSU or anything like that. For the cloud costs, I'm just using Azure published list prices, and all of you are very special customers for us, so you're all going to get discounts compared to this Azure published list price. So this is just assuming that anyone off the street can get this deal. All of you are smarter than that. You're going to get even a better deal than this. Note especially the last line here. I have included network egress costs. Now, as Ray mentioned earlier, they're part of the Internet 2 or the I2 consortium. So the I2 consortium has an agreement with Microsoft. When it connects to Azure, we waive the network egress fees. So that's a very, very significant cost savings for universities. And we didn't even take that into account over here. We just assumed that any customer, whether they're educational or not, whether they're part of the I2 consortium or not, they will get at least these savings. Any questions about that? All right, so with that, I'm going to turn it back to Jason.
Perfect. Thank you so much, Asif and Ray. Well, at this point, we've covered the San Diego State University story. We've provided you with the business use cases, the architecture, and the compelling reasons to consider the solution. And I have to say, Asif and I are frequently in conversations with customers that identify with this need to be able to move and manage these large terabyte and petabyte scale data sets. And Microsoft Azure and CloudLanes have delivered a great solution to resolve these issues. We showcased the economies of scale, the elastic capacity and capabilities that the cloud provides, and how the solution integrates with your existing investments on your existing virtual infrastructure to help our customers really modernize the data center through this more desirable OpEx versus CapEx approach. Now, as Asif was alluding to here at the end, for those customers on the line who are our EDU customers, CloudLanes has worked with us to put together a promotional offering. Keep in mind that you folks did receive a direct invitation from us at Microsoft. So this hasn't been brought out broadly. We specifically targeted the accounts on the West Coast. We're offering this particular promotion through April 15th. But what I want to show you here is sort of this upper level of the box and the Azure retail prices. These are more in alignment with what Asif was speaking to. But that's not what we're going to be asking you folks to be paying. CloudLanes has generously provided a discount on their CloudLanes product in a tiered fashion with the larger terabyte as we move to petabyte scale, as well as Microsoft is currently running a cool storage promo as well, where you can leverage your EES agreement or your Microsoft agreement to take advantage of, again, better tiered pricing. Now, some of this stuff that I'm showing you, all the way up to the 5 petabyte storage discount, that's getting it down to 0.54 cents per gigabyte per month. So this is much less than a penny. It gives you an opportunity to consider what those costs would be to actually buy a physical storage array on premise, as Asif was saying, versus buying basically a pre-commitment to a large storage volume out in Azure. So some very compelling reasons here to get in contact with us, with your Microsoft account team, and the folks at CloudLanes as we work together to deliver these types of solutions. If there are questions around this, please feel free to put them into the IM window. But again, I want to thank our presenters, Asif and Ray, as we transition now over to our Q&A portion of the presentation. If you'd like to take your phone off mute or leverage the IM window here, we'll have the folks here that actually deployed and implemented this solution on the call to answer those specific questions. So if there are any questions, please feel free to unmute and ask those now. Another thing I wanted to note too is Asif was referring to the Internet 2 egress waiver. If you're an education account and you have a Microsoft agreement in place, we've already waived up to 15% of any and all egress charges. So you don't necessarily need to be an Internet 2 customer in order to get that egress benefit as well. As an education customer, it's already built into your terms and conditions of your agreement. If you don't have at least 15% of your monthly consumption rate coming out as egress charges, we waive those charges altogether.
So I'll get this started. I know a big concern of SDSU was the high availability of the data, whether it's availability of the data on site or once it goes to the cloud. So can I ask CloudLanes to respond to that? How do we ensure high availability both on site and in the cloud?
Certainly. Thank you, Asif. And that's a great concern. All the times we get that question about the high availability. So we leverage stateless architecture along with the hypervisor support. So something like the vMotion or automatic failover from the Hyper-V clusters. We use those capabilities to protect the virtual machine from failing at any given point in time. That's the on-prem protection for the virtual machine from the high availability perspective. And the second piece is the cloud, where the data in transit or data going to the cloud is somewhere concerned. So what happens with CloudLanes in terms of the VTL protocol is we export the tape once the job is completed, and that tape is ejected to the cloud straight up. Now, if there is a problem and sometimes a timeout or maybe some kind of a disconnection that occurs on the network, we resend that data up to cloud automatically, and also log some of the information back there in the logs to ensure that the customers have a complete visibility on what's happening with their data in transit to the cloud. I hope that answers the question.
Great, thank you, Milan. Another question, and somebody asked this earlier, how many devices were used in the SDSU, or not devices, but how many CloudLanes appliances were used in the SDSU architecture, and how do you determine how many you need? Realizing, of course, that there's no cost for the VMs itself, so you can use as many as you want, but what's a design guideline for how many I need? Can I do everything with one? Do I need multiples of them?
Yeah, of course. That's again a very great question because that determines the real number of virtual machines and the resource allocation around that. So we have a couple of starting points to determine how many number of virtual machines you are going to require for any particular architecture. So for example, Ray answered that SDSU used three instances of CloudLanes on a physical box, but that necessarily, again, did not be a physical box, could be a virtual machine as well. So fundamentally, depending on the type of the workload and the number of ingest points from an on-prem infrastructure, for example, in SDSU's case, very particularly, there were 3 different points where the data is expected to come from in a VTL over the VTL protocol. So that's one of the points which allows us to determine how many number of instances would be appropriate. And to drill into that a little further, for example, you have Veeam, Commvault, and maybe EMC Networker, or maybe IBM Tivoli Storage Manager also sitting on the network due to the complexity of network's heterogeneous operating system support for your infrastructure. Now, what we recommend usually is if you have this kind of an architecture, you should probably look at a single instance per backup environment or per archive software environment, so that the virtual machines are dedicated and fully performant under the load supplied under the load they work from each of these applications.
Great. Another question. Unless somebody asks, I'll just keep asking questions.
Sure.
So we talked about the speed at which CloudLanes can send data up to the cloud. What if I don't have a 10 gig pipe? What if my bandwidth is fairly limited? Would this still be a good solution?
So the bandwidth is, of course, one of the very critical components of the solution that determines your time to offsite the data. But there are some calculations that we can do to compensate storage versus bandwidth and vice versa. So, for example, on a 1 Gbps connectivity, you'll be probably able to practically you'll be able to send something around 4 terabytes to 4.5 terabytes across 24 hours. But the backup sets are fairly larger than that. The daily backups or weekly backup sets are fairly larger than that capacity. So we could expand the landing zone to compensate the lack of bandwidth or the lesser amount of bandwidth available in those kind of scenarios. Again, to expand a little more on that, it is also, when we say the landing zone, it sometimes triggers as well that the software requires a huge landing zone. That's not the case. So, for example, you have multiple jobs running on the from a backup software or from an archiving application that is expected to tier the data all the way to CloudLanes. The largest job, the largest size job on your application, plus the amount of data and the transit period from on-premises to cloud will be combinedly calculated, and they will be put together to determine the overall landing zone there. So, if you have a backup that runs and creates a 150 terabyte of footprint on premises, you definitely don't require that whole 150 terabytes of footprint on premises available. It can be definitely lesser than that.
Ray mentioned that he uses 3 storage accounts, and Milan, you responded that the software supports up to 8 accounts. Can you talk about how many storage accounts you recommend, and what's the design thinking behind that?
Of course.
And what if I have a need for more than 8?
Of course. So we recommend using up to 2 storage accounts, although we definitely support 8 storage accounts there. Now, the real determination of the storage accounts to be added is fairly based on the amount of data that we expect to be handled. And of course, we use something called upload multiplexing technology along with the upload algorithms supported by cloud provider like Azure has some of them. We integrate with those. So to optimize the performance, the generally a two storage account configuration on a virtual machine would be appropriate. However, if you have really very fat pipes to internet, or maybe something like 10 gig express route or multiple of those kind of connections, you might want to add multiple of those accounts on the same virtual machine, provided you have a fairly performance-oriented storage, underlying storage provided to CloudLanes, because the read speed is also dependent of the spindles spinning under the hood. So you can go as high as 8. The recommended configuration is minimum 2 accounts, so that you have a fair amount of speed. And in SDSU's case, we use 3 accounts there to achieve a lot better upload performance to the Azure.
Great. Final question. To what extent do I need to learn the CloudLanes interface versus to what extent can I use my existing tools to manage my movement to the cloud? In other words, how disruptive is this?
Frankly, the overall idea of designing CloudLanes is to not drive the customers to learn something new all the way, because everybody is busy, and there are hundreds of technology coming across the board. Every year something new comes up. So our fundamental objective is to excuse me, less the more. So we don't complicate the interface at all. It's fairly simple, like you showed the dashboard during the presentation. It has some very unique values shown on the dashboard, so that an administrator of that virtual machine can really determine the health status and the performance status of how the data is going back and forth. But end of the day, we want our customers to be absolutely focused on their core job, and they should be really looking at what they have been doing for years. Something in this example, if you have a Veeam server, you know Veeam very well. You wouldn't want to learn another technology just to support your requirements. So your Veeam still stays your atomic unit of management, and we take all the overheads and the additional efforts, offload it to us, and we handle that in the background. So there's not a lot to learn as such from the management perspective of the virtual machine. There's the least complicated architecture you can imagine.
Atomic unit of management. I like that.
Yeah.
So we're running into our last few minutes. Jason, I'll turn it back to you.
Asif, there is one more question that came in the IM.
Oh, okay. Sorry, I didn't see that. Is there a reason we must have a VM in Azure to verify data? Can we have this as a local VM?
Oh yes, that's definitely another great question. So Brian, to answer your question, the reason we recommend you should have that running in Azure, because we want to be sure the data in transit from your data center perimeter network to the Azure's perimeter network, or rather right until the last hop in Azure before it gets to the Azure storage grids, is verified. Now, when I say it's verified, the data goes off your premises and it leaves your firewall. And we have seen some of these configurations where we were really struggling with one of the customers to find out why they couldn't send the data off to a storage account. And we figured out the firewall was actually doing some kind of decryption, SSL decryption, and TLS. It was trying TLS and SSL decryption on the outbound traffic, which led to several hundred issues altogether, right from the data integrity. Now, if the virtual machine is sitting on premises in those cases, the data verification, the virtual machine is going to say, well, I see the data as it was at the source, and your data is safe. But that's not a realistic picture. So that the data verification service has to be running in Azure, so you have, while your data crosses through multiple hops of the network, the virtual machine can still determine that it has the same data as it was originated from the source, and it is resting that data in Azure as the same data it received. I hope that answers the question, Brian.
Yeah, that's exactly what we were looking for. We were just thinking, well, if we were just verifying the current data that's there, there's really no need for it to be up there. This makes perfect sense if we're actually, analyzing the actual transfer of the data as well.
Yeah, perfect.
Is this Brian in Wyoming? Brian, is this Brian in Wyoming?
Yeah, that's correct. I'm sorry,
Hi.
I had you on.
Okay. Hi, Brian.
And just to add a little color to the verification, the data verification piece. Generally, when we say it could be a virtual machine, it is natural to assume that, well, I have to pay a lot of money for my compute also, but this can be a micro size virtual machine which costs the least amount to your Azure subscription. It's not necessarily be a virtual machine like A4 onwards, or maybe D4 class machine, but a standard machine starting from A1 or A0 also.
Perfect.
Yep.
Okay, great. Are there any other questions out there? I know that we're at about time here. We can hang on the line, though, for any additional questions. If there are any, if folks want to come off mute or put them into the IM window. That doesn't look to be the case. So with that, to our presenters, thank you so much, Asif and Ray and Milind, for fronting the questions here. We truly appreciate your time today. If you'd like to engage with us directly, I'll go ahead and put my my email address in the IM window as well. Otherwise, it is just jlucas, J-L-U-C-A-S, at Microsoft.com if you wanted to get direct engagement from your Microsoft team. Otherwise, with that, appreciate everyone's time today, and we'll conclude the recording. Thank you.